Good day, everyone. In this module, we will be discussing how we can mathematically describe heat conduction through a material. At the end of this module, it is expected that you will be able to identify the various conventions to express heat flow and temperature, describe how temperature varies with position and time within a heat conducting medium, explain how the heat conduction equation can be used to characterize the temperature distribution within a medium, and analyze the type of boundary and initial conditions present in a heat conduction problem. Now let us discuss a very simple example of expressing temperature and heat flow. Here are two statements regarding the condition of a heat conducting medium at the point where the heat starts to flow. The color gradient that shifts from red to orange denotes that the left side is hotter than the right side. Thus, heat flows from the left to the right of this object. Now the question is, are these two statements complete? Of course, I'm not talking about the sentence construction of these two statements, since grammatically both statements are complete. But when I ask you to evaluate their completeness, I am asking you this in the context of the thermal properties and processes that are occurring in this medium. Now the sentence above is already complete because remember, temperature is a scalar quantity. Therefore, we only need to specify the magnitude for it to be completely defined. It's like when you are asked, what is the temperature at this point? The logical answer to that is, the temperature at this point is this much. But when we say that heat flux on this surface is 50 watts per meter squared, we should ask, how does heat flow then? Is it to the right or to the left of this point? The reason why we should ask these follow-up questions is that heat is a vector quantity. Therefore, for you to completely express the rate of heat flow, you should specify its magnitude and direction. The direction of heat flow is denoted by the sign that we affix before the magnitude of the rate of heat flow. When we say that the rate of heat flow or the heat flux is positive, it means that the direction of heat flow is from the higher temperature point to the lower temperature point. But when we say that the rate of heat flow or heat flux is negative, then the real direction of heat flow is the reverse of what we specified. So if we assume that heat comes from the right to the left, then we found out from our calculations that the sign of heat is negative, then it means that the direction that we assumed all along for the heat flow is wrong.